first thing I want to do is just kind of go through some brick basics. This is a program that I developed for freshman architectural students and freshman construction science students. And it just basically explains how brick are made, what they are, some of the qualities, some of the properties of them. And I hope you find it interesting. I'll try not to put you to sleep. Engineers are very good at putting people to sleep, so if I see you doze off, I'll just walk by, and I've got this little architectural scale here. I can use that. Okay. Oh, by the way, I am an engineer. I'm a structural engineer. I've been working with ACme Brick for the last 13 years, and before that, I've had my own engineering practice. I've worked for a number of companies. Honestly, I prefer to work for someone else. There's a lot of work running your own company, but if that turns you on, you just go for it, because in this economy, you really have to find whatever work you can. I just also wanted to give you kind of an encouraging word. My son is 22. He just bought his first house on his 22nd birthday in March, and he doesn't have a college degree yet. He's taking courses at Tarrant Community College. He went to Texas Tech for a semester and didn't get along very well with the dorm life there. It was very difficult for him to study. So he's kind of gone on his own, but he's always been kind of a go-getter, going out and looking for a job. He managed to get a job with General Motors in their finance division doing IT security through a friend, just contacts. Your networking is very important. So there's things that you can do out there that will not only be lucrative, not only give you some good employment, but also hopefully give you a challenge in whatever you do. So I hope whatever you do in your life, you'll do what your passion is. A lot of people start out, they just want to get a job and make some money so they can enjoy their weekends in South Padre Island. That's fun. I was there this week. It's a great place. But there's a lot more to life than that, and you want to find something fulfilling to do. Well, that's enough marketing.
Will that work? Is that your clicker?
Yes.
Did you try it?
It was working. Yeah. I don't know what happened to it, but it was working. I put something else in it, probably messed it up.
You can just hit the down key.
Usually that works. It's scrolling through them on screen, but it's not changing.
Oh, because the slideshow's over there.
Yes.
Oh, I see. I don't know why that's not doing that. Give me that over
I've got
there.
2 presentations up. That might be part of it too. There we go. It's starting to move now. Let's see if it works with this. Okay, very good. All right, it's a Microsoft thing. This is an AIA presentation, and by the way, I could give you you can get a credit for this.
Me?
Yes. Okay. Continuing education credit. If you're an architect or a student architect, you can get credit for it. Okay, so we're a member. We are an AIA provider, and ACme Brick is also a member of U.S. Green Building Council. I'm a lead AP. I don't think I brought any cards with me, but I'll give you my contact information. Every material has its strengths and weaknesses, and different materials give you an opportunity to be creative. If you think about, for instance, structural steel, we know that as being very strong in tension. It's also very strong in compression until it gets to be long and thin, and then it has a tendency to buckle. Try to put a load on a piece of spaghetti, and that's lengthwise a compression load, and that gives you an idea of some of the issues that you run into with building materials. With masonry materials, we generally don't use long, thin. We don't build long, thin masonry columns. Possible exception would be if you go back to the Middle Ages and you look at some of the Gothic cathedrals where they had some very slender flying buttresses that were used in compression, and that was a real art to develop that. They obviously had a lot of technology behind it. It could have just been a seat of the pants, but I have a feeling they did. They really understood trigonometry and the properties of materials and how they would behave. They didn't use the modern techniques probably, but we developed those fairly recently, so they couldn't have. one of the things you want to do, whatever material you're working with, is focus on the strengths and weaknesses of that material, especially the strengths. You try to use the strengths. Allow for the weaknesses, but use the strength. Anyway, one of the things that we always try to do in ACme Brick presentations is make you feel very comfortable using brick. So I hope we'll have a little different perspective on brick at the end of the hour. Brick has been around a long, long time. The earliest reference anywhere in literature to fired clay brick was actually in the Bible in Genesis chapter 3. And they said, let us make brick and burn them thoroughly. And they had brick for stone and slime had they for mortar. Now, one of the things that the reason I like to mention this is that mortar does not need to be hard. It does not need to be very hard. It's confined in a really thin spot, and it's really a cushioning material more than it is intended to be extremely hard. If you make the mortar as hard as your brick or as hard as your stone, you're more likely to crack or crush the base material, the brick. Now, that doesn't happen very often anyway, but generally speaking, when you're designing with brick, you want the softest mortar that will do the job. The Brick Industry Association and the National Concrete Masonry Association both say that for their products. Brick has been around a long time. This is an aqueduct in Seville, Spain, I believe, and the brick is in really good condition. Actually, the mortar is in good condition too, considering that this is a Roman aqueduct, so it's almost 2,000 years old. And it's built with a fired clay brick, and the mortar has weathered a little bit, but what would you expect for 2,000 years? And the brick is not as hard as the brick that we make today. The brick we make today basically doesn't deteriorate in the weather, unless there's something wrong in the firing process. And I'll mention a couple things that can happen on that. You'll also notice that it's got some, what the Brits would call rendering, or we would call stucco on the outside of it attached to the brick, and that has fallen away. By the way, the Romans made a very good cement. If you look, have you ever heard of the document called De Architectura?
They probably won't.
No, have you? Okay, I'm sure you have as an architect. It was written by a man named Vesuvius around 120 BC, and it is a compendium of architectural knowledge for the time. One of the things that he puts in there is a formula for making mortar. You basically take volcanic ash from, say, Mount Vesuvius or Herculanum, or one of the volcanoes that had erupted at that time and left a lot of volcanic ash. And volcanic ash is a glassy material. It's very much like our fly ash that we generate burning powdered coal. And what they did is they just took that volcanic ash and they mixed it about 3 to 1 with lime. They would use a burnt lime, make it into a lime putty, and then they would put a certain amount of volcanic ash in it. And their cement that they made that way hardened very slowly, but it was extremely durable. They made concrete at that time in Parthenon. The Pantheon, I believe, was built, I'm not sure of the time on that, but it was right around, I think it was in AD, I think it was like maybe 100 AD or something like that. But they had concrete. Some of the shells that they built, the concrete was only 4-inch thick. It was unreinforced, and it has stood the test of time. It's been there for 2,000 years. So their concretes and their mortars were just extremely durable. So a good brick and a good mortar will last for literally thousands of years. This building is around 800 BC, and it is near Babylon, or actually it's in Nineveh, the city of Nineveh, which is now Fallujah in Iraq. And as you go through, they've unearthed this building, and you can see the arch has a little bit of deterioration. They've probably done a little bit of rebuilding, but those are original bricks that are almost 3,000 years old. So you can see that brick is a very durable material. This is the Colosseum in Rome that was built around 70 AD. And by the way, it's not the place where most of the gladiators fought. That was Circus Maximus. But it's a fairly large stadium. It's an oval, or it's actually an ellipse that's approximately 500 by 600 feet. And you can see it's multiple tiers of seating. The ground floor was actually, there are catacombs underneath it. All this was built entirely of clay brick. and they would put planks over the catacombs, and then they would put canvas over that, and about 3 inches of sand over top of that. By the way, anybody know the Latin word for sand? Anybody know the Spanish word for sand? Arena? Okay, that's where we get the word arena today. But this was where they did have gladiator fights in there, and the sand, I think, was to absorb the blood. I'm not sure. But anyway, that was kind of a little interesting aside. This stadium was big enough to stand 80,000 people, and they could seat 50,000. So it's a pretty good sized stadium. Of course, they didn't have all the ADA rules that we have today, so we need a little more space today. This is the Brunelleschi Dome in Florence, Italy, or if you're a purist, Fiorenza. But it is over 300 feet tall at this point. Oops, that's a touch screen, isn't it?
Yes, sorry.
It's over 300 feet tall. If you put the Washington, the Capitol Dome, nation's Capitol Dome, inside this building would come about to there. So it's quite a large building. There are actually people standing up there, but they're so small that you can't see them. It's a very large dome. It was built 1320 to 1400 AD. And the ribs are concrete, again, a pozzolanic concrete. And the shell of the dome is actually 2 layers of clay brick. A lot of the castles that you see in the medieval period were built of stone. This one was built of brick, and this is a poor man's castle. If you were rich, you built with cut stone, but if you couldn't afford that, then you built with fired clay brick. This is the Cathedral of Vasily the Blessed in Moscow, 1580 to 1588 it was constructed. It's claimed to be one of the most beautiful buildings in the world. I think you can see why. It's very ornate, a lot of arabesque type of style in it, and the onion skin domes are the only part of this building that are not clay brick. They used a lot of different colors of clay brick and glazed brick, and it's withstood 400 years of Moscow winters, which is a pretty good accomplishment. In modern times, this was a power plant on the Thames River near London, and I think it illustrates that a building to be functional doesn't necessarily have to be ugly. It was built kind of in an Art Deco style. My guess it was built in the 1930s. Probably restored. I would imagine that some of Hitler's bombs hit near there or possibly hit it. This is the Chrysler building, built in 1930. And it was, of course, a skyscraper built on a steel frame, but it's completely clad in a gray clay brick. And the top, of course, is stainless steel, the gargoyles and the roofing material. The only thing that hasn't been replaced on this building is the clay brick. The stainless steel has expanded and contracted and cracked where it leaked, and they had to go back and redo it and rework the joints. The gargoyles haven't been replaced, but the windows have all been replaced, and the clay brick has just stood the test of time. So it's again a very durable material. If you put it in a building, it will last indefinitely. Just be sure that the connectors, the fasteners that you fasten it to the wall system, are just as durable. The material that we typically build walls with, steel studs, things like that, are very susceptible to moisture damage. And so you need to protect that layer very well from moisture. Have a good water-resistant barrier, a good air barrier. Air infiltration can leak into a wall system, cause leaks. It causes condensation. So an air barrier is very important to protect the material, protect the structure behind it, unless you're building with concrete masonry and a brick veneer, and then you don't need to worry very much about it. But again, clay brick is extremely durable material. Now there's a very famous structure. How many of you have been there? This is the ballpark in Arlington. They changed the name of it, I think, to something else. Somebody sponsored it. It's now AT&T Stadium, I think, or something, AT&T Ballpark. But whoever has the money gets their name on it. This is a Ranger Red brick that we developed for the architect David O. Schwartz in Washington, D.C. Okay, let's talk about how brick are made. Initially, brick were made by hand. They were molded by hand, or perhaps you mix the clay with your feet, very much like you would stomp grapes. But This is a man mixing the clay, and it has to be mixed very thoroughly. You have to get the water distributed evenly through the clay, and that it takes a lot of work, just a lot of massaging to try to get the brick or to get the clay having the right properties. Brick is not quite as sensitive as pottery. Anybody worked with pottery in this class? Pottery is even more difficult because you're making really thin sections, and if you've got a little fault in it, of course it ruins the whole vessel. But with clay brick, it's not quite as sensitive as that. You need to get it to a certain consistency so it doesn't shrink and crack too much. But beyond that, you can form it in almost any shape that you want. The easiest shape, of course, is a rectangular shape, and that's what he's doing. He's dropping it into a mold. Now, if you notice this yellow stuff all around it, that's sand. He's using sand for a number of things. One is to help it dry out. The more sand that you mix into the clay, the less it's going to shrink. But the main thing he's doing here is he's got the mold lined with sand, and he's got the gob of clay covered with sand. It's like putting flour on some dough. If you've ever worked with bread dough, it's very sticky, and so is clay. You put sand on the outside, it makes it not so sticky. So when he puts it in the mold, it doesn't stick to the mold, and then he can demold it, make it into whatever shape he's got for the mold there, and then he puts it out in the sun to dry. It takes about 2 weeks to dry slowly. I should have said in the sun. You actually have to dry it in the shade, because if you put it in the sun, it'll just dry and crack. So they dry it in the shade, and then later on in the sun, get as much moisture out of it as possible, and then you stack it into, let's skip that. I don't have it. Okay, you stack it into something like a stove kill, and basically you build a stack of bricks with channels through it, with a place to build a fire, and very carefully fire it for approximately a week, and then you cover everything up, let it soak. You have to get it up around 2,000 degrees to be able to properly fire brick. Some of the softer fired brick were used here during the Middle Ages. They would actually carve the brick. This man is cutting it using a template with a diamond saw. Now, does that look like a diamond saw to you? It's actually a piece of copper wire and a bow saw, but the top copper wire, they've taken a hammer and beaten diamond chips into it, and they're using that to cut the brick. We still use that kind of technique today, except we're a little more sophisticated in how to arrange the diamonds, and we can also make industrial diamonds, which are much less expensive than natural diamonds. But a lot of carving of brick was done. Brick is a relatively hard material, but if you underfire it a little bit, you can carve it very intricately. And you'll find all over Europe carvings and buildings that date back to 500 or 600 years old, back to the 1400s, 1500s. Modern brick sculptures generally would carve the brick green. This is a sculpture that was done, I believe, by Paula Collins, but what she did is just arrange all these bricks on an easel. She would put a little strip of clay or some other material in to represent the spaces, to make up the spaces, and then brick were just carved right on the easel, the whole surface, and then she would take them off and number them so they could be assembled in the right order. Maybe she put glaze on the bricks before they were fired, or they could be fired with glaze afterwards, but generally you put them on before they're fired. And then these are also carved bricks, these little scroll work around the edges. I would guess you probably made a mold for those and did a lot of them, but there's just a lot of things you can do with brick, carve it just like pottery, and make a shape, make something artistic. This makes a good signature for a building. This is the one we have in our Little Rock, Arkansas sales office. Back in the more modern way of making brick, this is around 1900. And you can see it's a 1 horsepower device here. What this is called is a hug mill. And the horse goes around in a circle, which horses don't seem to mind doing very much. People do. But the horse goes around in a circle and turns this vertical shaft with paddles on it, which mixes the clay. It saves a lot of hand labor. Now, naturally, we have more modern devices than that. But a lot of machines like this were developed and stylized in the 19th century. This one, you can kind of see by the dress, is around 1820s. And so 19th century was the age of reason, or little, I guess guess it was considered the age of reason, part of it still. But anyway, there was a lot of pride in rational design and machine design and things like that. So you see a lot of machines like that. Today, we still fire brick. We fire it in some more modern devices. But this is a stove kiln I mentioned before that would be built in the 1900s, early 1900s. A lot of times, if you see brick on an old plantation house in Virginia or Texas or just anywhere, you'll see that. Of course, they used slave labor back then. We don't really advocate that anymore. But they would build a stove kiln like this, and it's just basically a big stack of bricks. There's a shell on the outside that's plastered over with clay, and they would build fires with wood or coal or whatever fuel was available. And these wooden things are called buckstays. They hold everything, hold the arches together. They would build the fire. There were metal plates over the top that they could close off, or they could close the wooden dampers at the bottom. But once they got the whole stack up to the right temperature, which took about a week of firing, very slowly at first, gradually raise the temperature, get all the moisture out of it, watch the stack at the top and see when the smoke turns from white to clear or black, then you know you've cooked all the moisture out of the brick, and then you can fire it up a little faster. But it was a real art. Sidney Poitier did a 2-hour special on CBS about 7 or 8 years ago on this. It's called The Last Brickmaker in America. You might want to look that up and download it if you can to watch it. It's an interesting little story. But anyway, back in the 19th century, then they developed periodic kilns. Well, I should say that they developed them then. The Romans had them, actually. The reason that brick kilns were built on the site was you just didn't have the transportation to carry things a long ways. You could go maybe by sailing ship, and up until the steamship, or the steam engine, there wasn't any way to transport heavy materials over land a long ways, so brick kilns were done on the site. But then with the invention of the steam engine and the steam locomotive in the early 1800s, you were able to transport materials a longer distance. So then they would build these round kilns where they could reuse them, put the brick in there and fire them much more efficiently, get more production out of the brick. With the stove kiln, by the way, you were lucky if you could get 50% of the brick that were suitably fired to use in the face of the building. The rest of them were used on the interior. We called them building brick. They were way under fired, but they were strong enough to carry some load, but they didn't have the weather resistance to put on the outside of the building. This kind of kiln would give you maybe 80% or 85% weather resistant brick. In modern brick making, we of course use a little more modern excavating equipment. That's a Letourneau scraper that was developed by R.G. Letourneau around the late 1920s, and it's the most efficient way to excavate material. It was used to build the Alaskan Highway. Any large earth-moving feat that you see today is built with this type of material, because you can scrape up the material in layers and then deposit it very quickly somewhere else, and then come back 30 miles an hour. Just keep moving material. It's a very efficient way to move earth. And we use those in mining clay because it takes the material off in layers. Clay is deposited in layers, and each layer has its own color variation. So you need to really be able to know what kind of clay you're getting when you fire brick. If your material changes, you're going to fire it and find out it's a different color. Almost all clay looks gray, unless you're in the East Coast. You have a lot of red clay there, because there's so much iron in it. But most of the clays we see around here are gray. Some will fire red, some will fire gray, some will fire brown, some will fire to almost white. So the ceramic engineers that work in the brick plants have to know what kind of clay they're getting. They'll take a sample and they'll fire it, test fire it, find out what temperature it starts to fuse at, and so forth. But it's mined very efficiently. Then it's mixed in a grinder to get the big lumps out of, especially limestone. A little limestone piece in there will it'll turn into lime and cause a lime pop, so that needs to be small enough to dissolve when it's fired. Pug mill mixes it thoroughly. This is about a 250 horsepower pug mill, and it mixes the clay so violently that when it's extruded out of a die, this is an extrusion die with cores in it. This is one that's operating. You see that column of brick is being extruded, and that comes out of there at several feet per second. If you put your hand on it, it would be so hot you wouldn't want to leave it very long. It's about 170 degrees. It will burn your hand if you leave it there very long. You can touch it quickly and it doesn't bother you. But that's just the extrusion process. Then we cut them up. Well, there's another line. What they're doing here is there's a little stainless steel wire. Whoops, touched it, didn't mean to. There's a stainless steel wire here that trims the face off the brick and the sides, and it leaves what we call a velour surface. You'll see if you see a velour cut brick, the velour surface is smooth, but it has little dimples in it. There's little pieces of aggregate that we call grog or sand in it, and as the wire cuts it, it drags those along the surface. And you'll notice that most brick that you'll see will be a wire cut face like that, and it gives a particular texture to the brick that you can notice. Now, after it's extruded, it'll be the wire cut again into individual bricks, and then these are stiff enough. The extrusion process, the clay is stiff enough that you can pick it up and it doesn't dent. You can press really hard with your thumb and it will dent, but it's stiff enough that it can be handled by hand or by robots. Most of it is handled by robots. It's stacked into what we call kill cars. K-I-L-N is pronounced either kill or kiln. Some people pronounce it that way. The traditional pronunciation is kill. And so it's stacked onto these kill cars, which are made of steel. They have fire clay on the bottom to protect the steel from the heat of the brick kiln. Steel will melt, and the steel would be very soft above 1100 Fahrenheit. We have to fire these brick up to 2000. So this is from our Elgin plant. If you know where Elgin is, it's just about 30 miles east of Austin. That's a brick plant that you could visit. There's one in Sealy, which is a little bit closer. But there's several that if you wanted to take a tour, we could probably arrange that. Okay, and then you can see how they're stacked on the kiln. These are ceramic, fire bricks at the bottom, specially shaped fire bricks designed to protect the steel from the heat. This is a long, narrow kiln in our Denton plant. And as it goes through, it takes about 2 days for the brick to move through the kiln, but it's a continuous process. They're moving maybe an inch every few seconds, and over about the kiln is about 400 feet long. And as it moves through, as you get to different places in the kiln, the temperature increases. So it increases very slowly at first. Well, it increases to a certain point. They have to slow it down around 1100 degrees Fahrenheit. Then they heat it up again to around 2000 degrees Fahrenheit. And then as it cools back down, they're bringing air back through the brick to cool the brick, but they preheat the air and use that to fire more brick. So it makes the firing process a little bit more efficient. It's a fairly efficient process. We've reduced the amount of energy to fire brick by about 80% since 1900, and about 30 or 40% since about 10 years ago. So we're doing everything we can to reduce the amount of energy required to fire the brick. And are we doing this out of the goodness of our heart to save the environment? Well, yes and no, but we're also doing it to save money because energy costs money. So if you really want to look at the sustainability of a product, you can look at the amount of energy used to produce it, but you can also look at what it costs, because if it costs more, then that a big factor is how much energy goes into producing it. This is what it looks like with the naked eye looking into a brick kiln, a port in a brick kiln, and it's not so bright that it would hurt your eyes. You can actually, it's fairly bright, but it's kind of a bright yellow. It's not a white light or anything that's going to blind you. But at 2000 degrees, that's what you see. The brick are actually red hot, and then on the firing surface, it's a little hotter than that. The idea of making a ceramic is that you have some hard particles in the ceramic that don't melt, but you also have some flux or some softer particles that melt and fuse together. And that's how all ceramics are made. Some ceramics, like porcelain, will fire at about 3,000 degrees. Clay brick fires at about 2,000 degrees Fahrenheit. And because it's fired at such a high temperature, it's extremely durable. And this is just a stack of brick in the yard, but they would go to a job site. The one characteristic of the clay brick is it does have a one-time temperature moisture expansion. So brick very seldom will crack from shrinkage, because they expand in the wall slightly. But you do have to allow for that, but with expansion joints. And we're talking about a tenth of an inch and 25 feet. It's not a whole lot of expansion, but it's something you need to allow for. There's some terminology that we use in the brick business that you might run into on the job site. Things like a bed joint, a head joint, bed joint being the horizontal joint, the head joint being the vertical joint, a soldier, which is a brick standing up, a stretcher, which is a brick lying down, like a stretcher would imply. Mud is a slang for mortar. Another term that you might see would be a withe, or W. Sometimes it's pronounced width, and it really means it's an old Anglo-Saxon word that means a leaf or a layer of brick in the wall, a vertical layer of brick in the wall. But you'll hear that used throughout the Americas or North America. You'll hear capa in Spanish, or in Britain and Europe you'll hear leaf or some equivalent of that. But it's a vertical layer of brick in the wall. And there are actually 6 positions of brick in the wall. The soldier, the sailor would be the cores turned outward, or it might be a solid, but it would be the flat face turned outward. The shiner, there's a little thing you can remember on this. When you see a soldier marching by, you see his narrow face, his shoulder. If you see a ship come into port, the sailors will be facing port because they're looking for someone on the shore, perhaps, or some place they want to go. And usually the first place the sailor goes would be a tavern, and as he gets more and more drunk, he might kind of be a shiner, or he might get a shiner if he gets in a fight. But as the SPs carry him out, you know which the SP is, right? Shore Patrol. As they carry him out, he would be on a stretcher. Now, if he's really dead drunk, they might take him to the morgue, and he'll be a header. Put him in head first or feet first. And if he gets a chill there and wakes up, he might roll over in his grave. Or in the morgue there, and that would be a roll-lock header. That's a little bit of a mnemonic that you might use to remember those 6 positions of brick in the wall. But you'll see those fairly commonly, and then you'll see bond patterns, which are combinations of those brick positions. Running bond is the most common, and basically you're just putting one brick over another, but you're placing a brick over the joint below so that they interlock and are stronger that way. You can, if you're building more than one withe or more than one thickness of brick in the wall, then you might have bond patterns like the common bond, where every 6th course is turned into the wall as a header that basically ties 2 withes together so that they act as a unit. Flemish bond, every other brick is turned into the wall, and that's a very beautiful pattern. You'll see that in colonial Williamsburg and a lot of older buildings. You'll see that pattern. And then there's an English bond where every other row is a header. And you can look on the internet and find lots of different bond patterns, different variations of that. And you'll see it in buildings if you look for it. As far as durability, there are two specifications that we use a lot in the brick industry. ASTM C216 is face brick or facing brick. C652 is hollow brick, and that is the same specification except that it allows for more than a 25% core area in the brick. And the hollow brick actually use less energy. The masons don't like it because the bigger holes, they use a lot more mortar in laying the brick. Paving brick is another specification. There's 2 specifications for that. And then there's a testing method. ASTM has testing methods and material specifications for almost anything. And I'm not going to bore you with all of those numbers, but I will say that it is important what grade of brick you choose. Corpus Christi is the northernmost limit where you should ever use a grade MW or medium weathering brick. A lot of the brick that are made in Mexico are medium weathering. Some of them say they're severe weathering, and then they come across, they haven't really thoroughly tested them. So even in Corpus, you might have a problem with horizontal brick on a brick shelf. So we would just recommend in the United States, always use a grade SW brick. So we don't recommend the MW. There is a map on ASTM 216, and they call this a medium weathering zone, this lighter red, but those are the areas where you really, anything north of Corpus Christi here, well, Corpus is right there, but anything north of there, you really should be using a grade SW brick or severe weathering brick. And this is a test, a lab test. We test everything in the lab, all of our brick runs. This was 1978. We haven't changed that test method very much since then. It's we do things like a saturation coefficient that give a good indication of durability. And again, I won't bore you with it. Minimum compression strength is 3,000 psi for a grade SW. 2,500 is well, the minimum of 2,500, but an average of 3,000 psi. As you can see, we're generally going to be much stronger than that. Brick and masonry products tend to be much stronger than they need to be. And there are also types of brick that have to do with dimension tolerances. There's an architectural grade. FBS would be or FBX could be an architectural grade. FBA would be a grade that doesn't have, or a type that has much looser tolerances. If you wanted to have a brick with a lot of distortions in it, maybe a tumbled brick, then you not want to call for an FBS or FBX. But those are the specifications. They allow certain amounts of chippage in the brick and certain amounts of distortion. Mortar is ASTM C270, and it goes back a long ways. I mentioned the Tower of Babel. The Greeks, the Egyptians used burned gypsum, which would be plaster of Paris. They used that for mortar. It's a dry climate. It doesn't work very well in wet climates. In about around 400 BC, the Romans and Greeks developed pozzolanic mortars. Oh, by the way, turn your cell phones on stun. I forgot. Jamestown, the settlers came over in 1607. Actually, the earliest colony was 1587, but that one didn't survive, Roanoke colony. But 1607, they used mortar made of lime and sand with a little bit of clay mixed in with it. They didn't have a way to make a hard cement mortar. And it served its purpose reasonably well. You can see buildings that are still standing in Williamsburg that were built in the around 1740. And of course in Europe they're much older buildings than that. In 1850 to 1900, Portland cement was developed and brought into this country, added to mortar for strength around 1870s. And so Portland and lime is actually your best mortar. You want to emphasize the lime. More lime means a softer mortar with less shrinkage that allows for movements. We generally recommend a type N mortar today, which is about 1 part lime, 1 part cement, 6 cubic feet of sand. And by the way, Vitruvius was the one who established that ratio, that 3-to-1 total lime cement ratio, or cement and sand ratio. Vitruvius developed that in 120 BC. So yeah, it's been around a long time. Masonry cements have been developed more recently. They're generally, some of them are very good quality, some of them are not. They tend to leak a lot more, leak water a lot more than a good Portland lime mortar. So we like to stay with Portland lime as much as possible. What the mortar does is it bonds units together. It also keeps them separated. If you take 2 bricks and stack them without mortar, you'll notice they'll have little hard spots and they'll rock. If you try to put a load on them, they might crush, they might crack. But mortar tends to separate them and seal them. It also seals against water getting into the wall. A good mortar should flex to accommodate small movements in the wall, and it also bonds, reinforcing into the brick. Also has a decorative effect. Mortar is about 20% of your wall surface. So the color of the mortar is going to have a big influence on what your wall surface looks like. When we place brick on mortar, water will be absorbed into the brick, and that basically draws cement paste into the brick and causes a bond. There are different patterns of joints that you can put in brick. The most common is a grapevine, is a concave pattern. It's basically a rounded tool that you tool the edge of the brick, the joint of the brick rather, and there's some V-shaped ones. Both of those will compress the mortar back into the brick and make a pretty strong wall that's moisture resistant. There are other patterns. This grapevine joint we used a lot in colonial Williamsburg. There's a beaded joint, which is kind of the little bead sticking out of the wall. There's a weathered joint, struck joint, flush joint, raked joint, extruded. And you can use any of these indoors. We recommend the concave and the V-joint outdoors where you have to keep the weather out. Mortar is always mixed to proportions in the field. There are property specifications where you can mix it to a certain strength, but that's done in a laboratory, and that's just to develop a different proportion. So the best mortar you're going to get is either with masonry cement, you'd use 2 bags of cement, 6 cubic feet of sand, which is 8 5-gallon pails, and a measured amount of water. We recommend for commercial work that you use basically 1 bag of Portland, 1 bag of lime. You can mix these in any of the commercial mixers. You mix them 3 to 5 minutes, and you'll have a good mortar. So stay with the type N mortar. Recommend that. Just try to remember type N. Okay, I'm not going to spend much more time on the mortar, but I'll just say that this is a building from the University of Texas. It's Scottish Rite dorm just north of the campus there. And the mortars, this was built in 1923. You can still see trowel marks in the mortar there. So a good, yes sir?
I thought you said stick with type N?
N, right, as in November, yes. You can still see trowel marks in the mortar. So the mortar, a good Portland lime type N mortar, which I believe is what this is, will last basically indefinitely. That's almost 100 years old now. It's 90 years old. There's no weathering of the mortar at all. The brick is not weathered at all. There is some Indiana limestone higher up in the building, and that is weathered very much. It's weathered about 1/4 of an inch, so that all the architectural carvings are just disintegrating. But the brick and mortar are extremely durable. There's specifications for mortar, for grout. I won't spend a lot of time on that. Mortar, the most important thing is good workability in the field. So you want a good workable mortar. Let the masonry contractor determine how much water to put in it to make it just as workable as he needs. But a good Portland lime, the higher the lime content, the more workable the mortar is. I'll show you some architectural details, some of the things that you can do with clay brick, and I want to leave some time to talk about some other things at the end here. This is that's a Kings Highway Christian Church in Shreveport, Louisiana. And this is just modular brick. There's nothing else on this building except a few little cast stone details, and it's about 100 years old. These keystones are cast stone. These thrust blocks on the bottoms of the arches are cast stone, and those little corbels out there that support the arches above, those are cast stone. The brick is a multi-withe brick. Remember what bond patterns we've talked about before? They're actually using the masonry, the brick, to bond 2 layers in the wall there. And you can see that's what kind of bond pattern? Anybody remember?
Come on.
That's a common bond, okay? But you see those headers are every so many courses there. And they put a lot of other details in here. Those bricks are laid at 45-degree angles so that the corner sticks out. Now, today, you'd look at that and say, oh, we don't want core holes exposed. But the core holes are exposed. They just basically let them fill up with mortar, and it's not a problem. It's far enough up on the wall, nobody notices or cares. And they're actually several layers of corbelling out. Corbel is when you step the brick out from below. You can actually see a corbel. Whoops. Did it again. You can actually see a corbel in those bricks that are sticking out. But they're in the shadows. You just really don't notice them. So, just a very creative bricklayer and architect, I'm sure, back in 100 years ago, using the products that he had and using them very creatively. Corbels are, again, stepping the brick out in the wall, and you can do do it in stages. Generally, we don't like to go more than about 3/4 of an inch per step. Part of that is because it exposed the holes. The holes are generally 3/4 of an inch back on the face of the brick, from the face of the brick. But that's one way of doing it. You can also do, of course, a face like this. Now, if you're doing a thin brick veneer, try to remember that this brick is leaning out. You're going to have to support it with something to tie it back into the wall. So we use ties. Well, the brick ties that we typically use commercially are 3/16 inch galvanized wire. That has a lifespan of 50 years or more. If you're building a building for a long time, a long-lived brick, you want to, or building, you know the brick is going to last 100 years or more, so you probably better try to use stainless steel ties or something that is going to last the same length of time. Just because we had buildings built 100 years ago that are still standing, a lot of those were just several layers of brick, and those don't deteriorate. But when you start putting maybe a metal stud system behind it, and those studs can corrode, or the fasteners that tie them together, you need to make sure that those are going to be durable. If it costs $20 to $30 a square foot to build a brick veneer, it probably makes sense to spend an extra 50 cents to $1 a square foot to put some stainless steel ties in it, if you want the building to last a while. So that's just something to keep in mind if you'll become architects, or if you go into construction science, you're working for a general contractor. You want to be aware that there are weak links in almost any kind of building system. Special shapes are available in clay brick and a lot of other materials that can be carved or cut or manufactured or extruded to a size that meets your needs, in this case, a column. There's an example of a column. You can judge the aesthetics of this one for yourself, but I'm not really thrilled with it, but it's got some, it depends. I mean, you're looking at a close-up of the building. If you stand back, you might find that it's very attractive. But again, aesthetics, beauty is in the eye of the beholder. Something that might appeal to you, a sign I saw one time is "Beauty is in the eye of the beer holder." It's all of perspective. There's a special shape that's used for a building that's coming together at a 135-degree angle, or if you go the other direction, a 45-degree angle. You basically need one special shape for this, but you use it over and over again. And that's relatively economical. If I can show it on the board here. Your wall looks like this. And you can use you use a special shape here for that 45-degree corner, and then use your regular shapes all the way back. Regular stretcher brick. But then when you come to the corner of the next course, obviously you need to flip it over because that would offset the joints. So basically use one special shape for that outside corner. Another special shape is something we call a water table. A water table was traditionally with masonry, when you had a basement, the wall would be thicker, and then as you went farther up on the building, the wall might be thinner, so you'd step it back on the surface, or you might step it back on the inside as well. But when you step it back at the surface, water could build up on a ledge. So what you do is you make a sloping shape that sheds the water off it. That's what we call a water table. You'll see a lot of shapes of that. It might be an OG curve, or it might just be a bevel like this one, but that is a water table shape. Now, there's cases where you might not need a special shape. If you're building a tight circle like that column, you would need a special shape, but if you're building a long curve like this, then you can just use normal bricks, and there'll be just a little bit of a shadow effect, but you don't notice it on a larger shape like this, larger section. But if you're building a tight column, another way of doing that would be, as they've done here, a little hard to see, but those are actually rowlocks, where instead of having the broad face sitting out, you have the narrow face sitting out, stepping out into the wall. And you can make a much tighter curve with that. You're just taking up the slope in the mortar itself. Arches can be built. Now, originally the Romans and others developed the arch to be able to span distances with a clay material or maybe material, and it it was used structurally. But in this case, we use them today, we use them mostly architecturally because our brick are veneer and they tend to be attached to the building. So when you build an arch, it's a little more troublesome. It's a little harder to build it well. What we tend to do today is, and soffits, brick soffits are the same thing. The Romans never would have done that. But what we do is we build them on a form, and then we have wire ties that go up into usually a concrete pour above it. So there are ways, probably don't need to memorize that, but there are ways of building and supporting arches that we use today. What?
How many days is supposed to be there?
How many what?
The arch?
How many days did that form work there?
The form, generally about 3 days for the mortar to reach sufficient strength. And likewise with concrete. Concrete can reach usually 2,000 or 3,000 psi in 3 days, or you can make it harder if you want, but you really don't need a whole lot of strength initially. It's just carrying the dead load. You design it conservatively and you don't have to leave the formwork under very long. 3 days to a week, whatever your construction schedule is. And the other thing that you'll notice when you build it on a form, you're going to have mortar sticking down on the surface like that, which you can't tool until you take the form away. So generally what they'll do is either put a backer rod in there, just a little soft foam piece in there to separate the bricks, and then come back later and you can retool the joints. Or you can use sand. You can see the backer rod sticking out there in that particular arch. And brick blends very well with other types of materials on the site. In this case, these are, I believe that's a steel tube structure with glazing in it. Brick is very versatile. You can build around an existing shape with it. Once the shape is there, the bricklayer can build around it and make things fit. Brick is in small pieces, so there's generally very little waste. Maybe you'll have to cut a piece, and you can, the small amount of waste that they have can be put in a special dumpster and taken to a concrete crushing plant, used for aggregate, or it can be crushed and used for mulch. You'll see crushed brick mulch at the Home Depot. So anything that is a waste can be reused. And it works very well with concrete products like this, these cast stone arches, sloping sills. There are a lot of things that can be done with brick. Special details on that, which I won't get into, but you actually have to build a roof underneath it. Brick can be arranged in polychrome patterns where you have multiple colors of brick. In this case, it's built into kind of a tartan weave woven fabric. At least that's the appearance of it. And when you build patterns like this, obviously it costs a little bit more to lay the brick because the bricklayer has to follow that pattern kind of carefully. So a pattern like this would probably cost in labor about twice as much. Typically you're looking at material in the wall costing about maybe $2 or $3 a square foot. The labor to put it up, it might be $10 to $15 a square foot. So the material is relatively inexpensive, and the labor is going to be the bulk of it. This is arranged to make it look like massive stones. You could have used a dark mortar, a matching mortar, and made it look even more convincing. But that's the look the architect wanted there. And that's actually a glazed brick, I believe. It might be a white brick, but I believe it's a glazed brick arranged into a pattern in the wall. There's another example. This is a light and dark brick on this chase bank. In this case, a white and a gray brick are blended together. This is actually an expansion joint in the brick, and they're using that feature to make it look like the line is there on purpose rather than just provide an expansion joint. And if you can build your expansion joints into patterns like that, they become much less visible than if you just put one in the middle of the wall. And then at the bottom is a gray concrete block, which blends very well with it. By the way, concrete block shrinks, brick expands, so you do have to allow for that little differential movement. Brick also works with cast-in-place concrete. That's a different coursing pattern there, a different pattern called a diaper coursing. This is a building at University of Louisiana Monroe. I think it's a student union or a library building, I'm not sure which. But close up there, these little things, these bands in there that could be a balustrade, is a balustrade up there, a balcony railing. These these are actually brick that are laid at 45 degrees to each other, and giving a really interesting texture to the building that at a distance could be precast, but as you get closer, you see that you have the detail of the brick that makes it even more attractive. Bands of brick used to frame windows with a different color field. And again, the same done here in the Rangers ballpark. This is the Meunier chocolate factory in Paris with a polychrome brick pattern. Workmanship is very important. Any time you build something in the field, whatever it is, you have to watch the people that are working for you. A good bricklayer can be a real artisan. That's kind of the end of that presentation. I would like to now show you some other things that you might find useful. I'm going to go to our website, the right one here. And just show you some tools that are available. Where was I? Okay. We'll go to the architectural tools first. And there's a color selection guide where you can basically go through and pick a brick pattern, see what it looks like in a wall panel. Takes a little while sometimes. Okay, for it to arrange. You can actually choose the mortar color, you can choose the bond patterns. Well, actually, this is just a running bond. There is a program on there that allows you to arrange the brick in the wall in any bond pattern and mortar color, and it's called Masonry Designer. I won't load that at this point just for the sake of time, but let's see. Guess I want this one. Nope. Let's go back. Okay. There is the Masonry Designer is another tool, and you can see it kind of highlights there, and that's the one that allows you to arrange different bond patterns. I'll let you try that out on your own because I don't want to take too much time with it here. There's some documents in there, lead and sustainability of brick, special shapes and things like that. For the builder, there's something called a pocket guide, and I've downloaded that on the site here, so if you can look that up later. The architect, there's a document in here that's quite large that I've downloaded because it is large. It's on the web. It's on this machine right here, so you can get it later. Let's see. The home buyer can actually if he wants to see what our brick would look like ahead of time, he can put a zip code in there first of all, and it'll list the bricks that are available within a reasonable shipping distance, and you can select the color of the brick, and then he can display it on a house that resembles the house, maybe 8 or 10 houses. Pick one that kind of resembles the house that he's building. And anyway, there's just a lot of resources available on the website. Now, so I don't have to wait for things to download. I'm just going to go to the folder that we were in. Okay. I'll show you the pocket guide just very quickly. It's a PDF document. A little slow loading, but it's just a resource that has all kinds of information in it, definitions, any kind of brick terms are just thoroughly defined in there. We've gone through and spent a lot of time just making sure we had accurate definitions.
I'll put that on the canvas.
Let's move along here. A lot of information that you may or may not find useful, but there's information for designing steel lintels over doorways, and just anything that you might do with a brick veneer. You're going to find that in the pocket guide. I'll close that. Okay. Let's see. Oh, there we go. All right. there's some technical services digests in there. This one, let's see if I got the right one. This one's on sustainable brick material, and it talks about LEED. This is based on LEED 2002, so it's a little bit dated, but or LEED 2.0. But the principles, all of the principles in it apply. The points are not accurate. They would not apply to LEED 4.0, which is coming out right now. And let's see what else. Okay, this one you might find interesting. It's an article on single white brick fences. A lot of those have been built throughout Texas, and a lot of them are failing because they haven't followed this guide. It's something. It's actually a structural system that needs to have the wire carefully placed in the right places, but it does make an attractive fence around a development if that's of interest to you. And no, don't think I need to get into that one. This one is a Brick Basics interior, and this is one that I developed for an interior design class, and I'll run that by you too because we have a few minutes left. I wanted to talk more about the basics first. Let's see, is this running? Yeah, that's it. Click through this. What's that?
The screen before the list of all the people. Yes.
That one?
Yeah. Which one? Now the ACme and
Oh,
vendors.
these 5 companies are basically, and plus we have actually 2 more now, Jenkins Brick, and there's one, we have one for interior floor coverings. ACme owns a lot of different masonry companies. IVP is a glass block grid system. You've noticed some glass block on this wall, and that's an aluminum frame grid system that you can install just like a window frame into a rough opening in a wood frame or steel frame wall. American Tile, as the name explains, is just basically floor tile. Texas Quarries is the natural stone division of ACme Brick. Featherlight is the concrete block division, and then of course ACme Brick. So all of those products can be used interior or exterior, and I'll just go through kind of briefly. The other thing I didn't mention was there's a Revit plugin. If you're working with Revit, 2011 through 2008, I think it was all the way back to 2008 through 2013, there is a plugin that allows you to insert ACme Brick with all of its properties and into Revit. I think it's got some concrete masonry properties as well, or products as well. So most of the companies that manufacture masonry products are building Revit plugins. I think we're the first to come up with it, but those are available if you're working in Revit. Masonry buildings last a lot longer than other materials. They have very little maintenance, very little life cycle costs, even though the masonry building might cost more initially. It has a lower life cycle cost. And if you're using it indoors, it can actually contribute to the indoor environment because a lot of the materials in light framed walls, especially if there's OSB and wood products, they tend to off-gas formaldehyde and some other things. And if you're using wood products, make sure you select one that doesn't have what they call volatile organic compounds. So masonry gives you a very clean indoor environment with nothing toxic in it that can get into your system, except when you saw it. When you're constructing it, you need to control the silica dust. That's a respiratory hazard, but we have ways of dealing with that. But just gives you some of the ideas. You might have brick walls inside, as in this school. You might have ceramic tile floors with very low maintenance, and we haven't developed a brick ceiling yet. That's a concrete masonry block. It's interior school in Mansfield, Pennsylvania. Mansfield, Texas. Excuse me. And that's combinations of split face and burnished or polished block. Just basically no volatile organic compounds or allergens. This is a school, this is a library at a school in Easter, Texas, which is northwest of Fort Worth, and exposed masonry helps control your indoor environment, helps control the temperature and humidity, because masonry is basically, when it's dry, it can absorb extra moisture in the air without damage at all. And also it tends to store temperature, keep things constant temperature. We have sound block type of material that can be used inside an auditorium, for instance, or perhaps in a lunchroom or classroom to absorb excess sound. Masonry itself has very low sound transmission. Sound transmission class of 50 or more doesn't allow excess sound to go through the wall. Those are sound blocks in this gymnasium. And the nice thing, there are other sound absorbing materials, but how many of them can you bounce a basketball off without damaging it? This is what do you call a band room, cafeterias, things like that. It's very useful. There's a whole system on LEED. You can look those up yourself. Some of the things that you can do with masonry, recycled materials, regional materials that you can, we very seldom ship masonry more than about 120 miles. So it's generally well within the 500-mile limits that LEED documents place on your building materials. Very low packaging, very little construction waste. Some of the advantages that you'll see. Embodied energy is, clay brick is moderate. It's not as high as a lot of Portland cement materials. It's actually not as high as concrete block as far as the amount of energy required to manufacture it. So it has a fairly low embodied energy. We're working all the time to make that lower. And that's just kind of a list of how much we've reduced. I think since 2003 we've reduced our embodied energy another 12%. So we're working with technology to try to reduce the firing energy, basically. And environmental quality, I'll skip over a lot of that. One of the things that ACme Brick does is we do try to support our customers in person, print, online, and I'm part of the in-person part. So if you need to contact me, you can send me an email, jswink@brick.com, JSWINK @brick.com. You'll probably find it in the presentation somewhere as well. I think it's probably the last page here. That's our family of companies that you asked about before. We've recently acquired Jenkins Brick in Alabama. It's 3 brick plants there, including one that runs on 50% landfill gas that helps reduce the embodied energy in that product. And we do sell products with other brick manufacturers, depending on the region we're in. Robinson Brick in Denver area, Lawrence. We also have a plant in the Denver area. Featherlight concrete block. This is that sea trace that I was telling you about earlier. That's a natural stone product that looks like a bed of worms, but it's really kind of a neat looking product. That's found. This picture right here is taken from the Texas Tech Student Union. Elgin Butler is a company in Elgin, Texas that makes a glazed ceramic tile, a structural tile. It's actually extruded up to a 4x8, 8x16. It's an extruded glazed ceramic tile rather, and it can be used for walls. And this is Peaster High School, the same one we saw before, but they used glazed ceramic tile in the quarters there. And it's very durable. It's very unlikely that anybody's going to damage that.
It can be cleaned easily.
Easily cleaned. Right? If you tried to put a magic marker on there and it would just wipe right off. And you can see it's very attractive. And there's a concrete masonry again in the Peaster High School. And with ceramic tile, you can get almost any color you want. It's very bright colors to very subdued colors. It can resemble natural stone or almost anything else. And of course, you can get bright colors with other cladding materials, but you can't get anything that can stay out in the weather, that will never fade and just never deteriorate in the weather. The Drexler building, if you remember, that was a glazed gray brick. It was built in 1930. So it has the potential for being, or it will last a long, long time. Just some examples of schools. These were award-winning schools that from the Golden Trowel Awards, I believe, is what this award process was. Anyway, I'll leave these slides on, or leave the presentation on this machine so you can go through and review them if you like. Again, brick sculptures. That's all I have, and we're just about out of time.
Anybody have any questions?
Questions?
Quick question?
Yes. Thank you so much for your everything today. So you introduced many things about the brick. Today I recognized the brick is main materials for the building.
Yeah.
So I have a question, two questions. One of them is you told us about the lead. It's like a environmental material. Environmental lead, LEED.
Oh, LEED.
Yeah, so
Yes, Lee.
I don't know what is a brick for environmental material?
Well, there are a number of things. First of all, it's a regional material, and there's a whole section in LEED, all of the LEED versions, including 4.0, for regional materials. We can use up to about 20% recycled material within the brick. Some other materials can use more. Durability is a tremendous sustainable issue that is not really recognized in LEED. It is recognized with 1 point in the Canadian LEED standard, but in the US GBC, there's no recognition of durability. However, there is in the LEED process, you do declare the service life of your building. And if you have a material that you know to be durable, as brick is and some other materials, you can design for a longer service life, perhaps, in the LEED process. One of the things that I think is the most important part of sustainability is to build a building that you don't have to rebuild 30 years later. Your average commercial building in the United States is torn down in 30 years and rebuilt. That doesn't have to happen, and that's not a very sustainable. The most damage to the environment occurs during construction, where you're bringing in all the equipment to regrade, and you're just chewing up the landscape. If you can do that, if you can build a building that lasts 100 years, you're actually recycling the entire building every 30 years. So, in our view, that's the most sustainable building that you can build. But you also want to build in good energy performance, and that's easy enough to do with insulating materials. They can be easily protected. The masonry does a good job of protecting materials like urethane foams that could be damaged by sunlight, but you can incorporate that within multiple layers of masonry and make a very